So in this class, I am going to give a case study on the rehabilitation and the retrofitting of the structure. So we know that what is the theory of the rehabilitation and retrofitting of the structure. So rehabilitation and retrofitting of the structure is nothing but, so if the structure is to be deteriorated or if the structure is to be old, so what are the possible cracks are there, what is the possible defects are there, we have to identify. So after that we have to rectify those. That subject is to be called as rehabilitation and retrofitting of the structure. Retrofitting means again fitting. So original fitting is different, retrofitting is to be different. Suppose if the structure is to be constructed for the 20 years or 30 years, after 10 years or 15 years, the structure is to be deteriorated, some problems, either the cracks or the slab leakage or the column leakage or the beam leakage or the seepage of seepage losses or the anything we have to be observed. So these are called as the problems or the decays is to be observed in the buildings. So that's why we have to again fit the structure with the help of doing some things. So in this class, I am going to discuss about a case study on the Mangalore site itself. Okay, so this warehouse. So warehouse is nothing but we have to store the rice bags or the wheat bags or any other bags. So in the Mangalore itself, I had to take a warehouse. So determining the structural health of the warehouse located in the Mangalore. The case study is first is that what is the physical inspection of the structure itself. The structure is to be constructed either the 10 years old or 20 years old or 30 years old. After that, we are going to the site and we have to take the photographs. So in the plan, we are going to see all the rooms, we are going to take the photographs. Suppose if anything is to be observed, either the cracks or the leakages or anything is to be observed or the decay of the structure is to be observed, we have to take the photographs physically. After that, we have to verify the physically. After that, we have to take the photographs. So with the observation or the clear inspection of the photographs, we have to conclude that what is the problem is to be there with the either the leakage or the slab expansion or any other things. What is the possible reason is that based on the photographs and physical inspection, we have to see that. So name and address of the building, year of the construction is 1972-73. So the building is to be constructed in the 1972-73. Type of the building is partially RCC. So it is not a fully RCC building. So some part is RCC, some part is partial, not RCC itself. So number of the story of the building is only single story only. So this building is to be constructed in the 1972-73. Partially RCC structure constructed in the single story means only one story. So this is the warehouse. So warehouse is nothing but in the Hyderabad also we are having the warehouses in Eragad and other things. So central warehouse corporation, central government will take care to store the rice bags in the so many thousands of the bags, wheat or any other thing supplied to the consumers. So the supply, civil supplies. So civil supply, they are supplied either the rice or wheat or any other thing. So those are to be stored in the large buildings called as the warehouse. So central warehouse corporation, it is to be dealt by the central government. So description of the uses of the building is warehouse. 5 top of the roofing AC sheets with the steel truss. So this building is nothing but consists of the not RCC slab 5 AC sheet with the steel truss building. So in this I have to observe what are the problems are to be, I have to be observed physically in a particular building. So hairline cracks. So what is hairline cracks? These are to be observed in highest number on the structure itself. So mainly we can observe these cracks on horizontal members. Horizontal members, and these hairline cracks are formed mainly due to the temperature stresses. So in the strength of materials, we are going to study about the thermal stresses. So due to the temperature variations, the building will be subjected to some deterioration because of the variation of the temperature, either the thermal stress or the thermal strain, we are getting the modulus of elasticity also. So due to the variation of the temperature, we are getting the variation of the stresses, variation of the strains. So because of that, we are getting the hard-line cracks on the horizontal members. Horizontal members means in the beam. Beam is a structural member, horizontal member. Column is a vertical compression member. So slab is a plate. Is it right or not? So these cracks, hard-line cracks, are mainly formed on the horizontal members, either the beams or floor or any other things. So these are formed because of due to the temperature stresses. So I told already, temperature stress means because of the temperature variations. Normal temperature is to be 21 degrees centigrade. Sometimes it will be 25 degrees centigrade. Sometimes it is the 45 degrees centigrade. So because of the variation of the temperatures within the particular area or the within particular locality, we are getting the different type of the thermal stresses. So next, wider cracks. So this is also seen on the diagram also. This is the horizontal cracks, also called as hairline cracks, HARLINE cracks. Next, wider cracks. So wider cracks are mainly observed on the vertical members. So hairline cracks are mainly observed on the horizontal members like the beam, and beam is a structural member subjected to the bending stresses. So what is the function of the beam? So whatever the load acting on the slab, it will transmit to the beam itself. Whatever the load coming from the slab to the beam transfer to the column itself. Whatever the loads coming from the slab, beam and column are equally transferred to the particular footing itself, either isolated footing or combined footing or wrapped footing or whatever the footing. So this is the function of the transfer of the load mechanism in the buildings itself. So that's why hard-line cracks are mainly formed on the horizontal members, and that is the beams itself. These are occurred because of the thermal stresses only. Thermal stresses means temperature stresses. Both are same. Either the thermal stress or the temperature stresses, both are same because of the variation of the temperature within a particular locality or within a room or within a building, within a structure, we are getting the different type of the temperature stresses. And next, wider cracks. Wider cracks are mainly formed on the vertical members like the column, which are caused by stress developed inside the column due to the corrosion. So my dear students, we have to observe what is the hairline cracks, what is the wider cracks. So where it is to be formed, hairline cracks, where it is to be formed on the wider cracks. Hairline cracks are the cracks formed on the only horizontal surfaces of the members like the beams itself. These are formed because of the temperature stresses or the thermal stresses. In the similar way, wider cracks are formed on the vertical members like the columns. These are formed due to the stresses developed inside the column due to the corrosion. I told already in the yesterday class also, corrosion of the steel reinforcement. Corrosion of the steel reinforcement means if the reinforcement is exposed to the atmosphere, automatically rusting will be occurs. That is called as the corrosion. So due to the corrosion of the steel inside the reinforcement, what forms the spalling of the concrete will be developed, and at the same time the strength of the concrete will reduce. At the same time, the strength of the yield strength of the steel is also reduced. So these are all we are having the disadvantages. Yesterday we had discussed in the corrosion of the steel reinforcement in the earlier class. So because of the corrosion of the steel reinforcement inside the column, the stresses will be developed. So because of those stresses developed because of the corrosion of the reinforcement inside the column, we are getting the wider cracks. So that is the story about hairline cracks and the wider cracks. And the hairline cracks are the horizontal members form. So main because of the thermal stresses or the temperature stresses. Is it okay? Is it clear? So that is only the beam member. Beam is a horizontal member. So columns, vertical members. So the wider cracks are formed mainly on the vertical members like the columns itself. Column is a purely compression member. Because of these are formed because of the stresses developed inside the column will be subjected to the corrosion. Next, coming to the spalling. So yesterday I told because of the corrosion of the steel reinforcement, the spalling of the concrete will be occurs. So because of the spalling of the concrete, we are getting the reduction of the compressive strength of the concrete, and at the same time we are getting the reduction of the yield strength of the steel also. So that's why we are getting the dual disadvantages because of the corrosion of the steel reinforcement. Spalling, what is the spalling? Spalling of the concrete cover as well as the plaster can be seen extremely mainly in columns, and as the masonry walls also light in beams. So what I observed in the present case of the Mangalore warehouse is to be the spalling of the concrete is to be occurred mainly in the walls, that is the brick walls. This is not the so this is a brick wall only, this is not a shear wall. So the spalling of the concrete is to be observed on the Mangalore site of the 5 warehouses is to be only on the brick walls as well as the mainly in the columns and light in beams only. So mainly in the walls only. So the spalling of the concrete is to be mainly occurred on the walls as well as the sometimes in the beams, sometimes in the columns also. So this is happened due to the debonding of the concrete from the reinforcement. My dear students, we had already discussed in the design of the RCC structures what is the bond, what is the cover, what is the shear, what is the torsion, everything we are going to discuss in the IS 456 2000. Design of the RCC structures, how to design the beam, how to design the column, how to design the slab, how to design the footing, how to design the shear wall, how to design the water tank, either the rectangular or the square or the trapezoidal or hexagonal, whatever it may be. So this spalling is to be occurred because of the debonding of the concrete and steel. So the bond will be very good, just like the father and mother in our family, a teacher and student in the college. So good bond between the steel and concrete. Otherwise, the spalling of the concrete. Why? Because it should be stick with each other. The reinforcement and concrete with stick with each other. That is called the RCC building, reinforced cement concrete building. So then only the structure will be safe against both tensile stresses as well as the compressive stresses. And so tension will be developed because of the pull, compression will be developed because of the push. So that's why we are using steel as a reinforcement and for reducing, for getting up the compressive strength, we are using the concrete. So concrete is a heterogeneous material, steel is a homogeneous material. Steel is only single material, whereas concrete has a cement, fine aggregate, coarse aggregate, water, admixtures and any other substitute materials also. Instead of cement, we are using cement and fly ash, cement and GGBS, cement and metacoline, cement and silica fume, whatever the materials we are going to use, there is no doubt about that. So instead of the fine aggregate sand, we are using sand and sand dust also. Instead of the coarse aggregate 20 mm, we are using 12 mm, 6 mm, 10 mm also. There is no problem about that. Ultimately, we are getting our required bond strength. So that's why what I am trying to explain is to be the good bond between the reinforcement and the concrete. Otherwise, spalling of the concrete will be occurs. So far we have discussed about what is the case study. This is the case study of the Mangalore in the Karnataka state, 1972-73. The building has to be constructed. This building is a warehouse. Warehouse is nothing but storage of the bulk quantity of the rice bags, bulk quantity of the wheat bags or any other things. So this is organized by the central government, Central Warehousing Corporation, New Delhi, central government organizations. Why? Because without any damage to a particular material stored in that is the very, very important thing. So in this we are seeing so far what is the spalling of the concrete, what is the wider cracks, what is the halane cracks. So after that we are going for cavity. Cavity means in our teeth also, our teeth are having cavity. Cavity means there will be a disturbance or there will be a flush between one teeth to the other teeth. So cavity is to be observed as in case of the structure is to be in the vertical members, mainly at the bottom level. So I think that you are having the doubt, you know about how halane cracks, how to wider cracks are observed, how to the spalling of the concrete. The cavity is to be mainly observed in the bottom of the concrete, column itself. So column is consist of the reinforcement and the concrete, the main bars and the distribution bars. The cavity is to be observed in the bottom of the column member. Acid and chemical attacks are responsible for internal cavity. I think that you are having the doubt why the cavity will be formed. So, my dear students, at each and every topic, you have to ask yourself why this subject is to be required. What is the cavity? Why cavity is to be occurs? So, what is the reason for occurring of the cavity? How to prevent that cavity is to be formed? So, first of all, we have to reduce the formation of the cavity. And suppose the cavity is already formed in the bottom of the column member, we don't bother about that. How to reduce that? That is the another thing. Prevention, and prevention is better than cure itself. So what is the remedial measures? What is the preventive measures? So remedial measures is already happened. What type of action we are going to take to meet that particular thing? Remedial measures is for further losses. What are the guidelines we are going to follow? That is the remedial measures. Preventive measures means already happened. Suppose if incident is already happened, what is the possible thing you have to take immediately on the site itself? Those are the preventive measures. Remedial measures means for future accidents what are the methods we are going to follow, what are the methodology we are going to adopt, what are the guidelines we are going to adopt. So, acid and chemical attacks are mainly responsible for internal cavity as well as the honeycombing of the concrete also. Honeycomb means the voids will be forms. So, if the vibration is to be not done properly, the voids will be forms in particular places of the slabs or beams or columns. We have to fill with the concrete only, don't fill with the mortar. So, otherwise what happens, the air will be entered into the reinforcement itself. In the meantime, not in a particular day or a particular month, a long time, the corrosion will be occurs. If the corrosion will be occurs, automatically spalling of the concrete will be occurs, the compressive strength of the concrete will be reduced, yield strength of the steel will be reduced, the steel rod, the cross-sectional area is also reduced. Yesterday I had discussed it. Suppose instead of 12 mm, if the corrosion will be occurs, the 12 mm will be reduced to the 10 mm. 10 mm will be reduced to the 8 mm, 8 mm will be reduced to 6 mm, may or may not be, because of the seriousness of the effectiveness of the corrosion of the steel reinforcement. Next, I will go to the environmental effect. What is the environmental effect? The structure is to be located near the harbour end. So, the Mangalore warehouse is to be located near the harbour, which is extremely exposed to the chloride contents. I told already in the yesterday class also, rapid chloride permeability test is to be done in the laboratory, whether the concrete is to be subjected to chloride contents. If this concrete is subjected to chloride contents, whether these are permissible limits or not, we have to see. So, that is to be done with the help of the rapid chloride permeability test, RCPT. So, RCPT, we are generating the electricity through the concrete cube. We have to see that how much chloride content is to be present, okay, and many acid attacks also. So, when the structure is alternately exposed to drying and wetting cycles also, sometimes the concrete will be subjected to drying conditions. Drying conditions means in the summer, wetting conditions means in the rainy season. So, the concrete will be subjected to the drying cycle as well as the wetting cycle also. So, it will be subjected to rainy season, it will be subjected to the cold season, it will be subjected to summer also. So, drying and wetting both are, it will be affected. Resulted in the crystallization of the salts in the porous caused the stress, resulted in the formation of the crack. Those cracks are called as environmental effects. Are you followed my thing? So, because of the environmental effect, so this site is to be located near the harbour. Because of the salt water in the sea, the chloride content will be affected the particular concrete itself. So, that is why because of the drying and wetting cycle subjected to the concrete, some cracks will be developed. So, that is the environmental effect. So, we are seeing the wider cracks, hailing cracks, and this environmental effect, and another thing is to be the spalling of the concrete. Next, we will go to the roof truss. The proposed truss is to be highly damaged due to the corrosion. And so, we had already studied in the design of the steel structures what is the roof truss. We are having a different type of the roof trusses, either the king post truss or the queen post truss, or there are so many trusses are there based on the span, based on the height also we are going to decide. Suppose for the parking purpose, instead of the RCC buildings, we are going to provide the trusses itself. In the factories also, industries also, we don't want to go for RCC buildings. The cost will be more, and that is also not suitable for the factories and the erection of the machines also. For if you see in our Hyderabad also, Balanagar, Jidmetla area, Metal area, so many trusses are there. In the trusses, we are going to fix the machines, and we have to generate the so many fabrication of the things. For the fabrication purpose, for the industrial purpose, we are going to go for the trusses. This is also a truss member. So what I observed in a particular case is to be Mangalore case, the truss is highly damaged due to the corrosion itself, and the bracing joints are broken. The proposed truss become wrinkled. So whatever the joints is also broken because of the spalling of the concrete as well as the corrosion also. Testing of the structure. So how to test the structure? As per Indian standards, the existing set is to be imposed on the non-destructive test. So what is meant by non-destructive test? Without disturbing a particular structure, we have to be tested whether it is the compressive strength is to be okay or not. We have to be tested without disturbing the particular structure itself. Ideally, without any damages. First one is the rebound hammer test. Second one is delamination sounding method. Third one is the carbonation method. pH test, ultrasonic pulse velocity test, cover meter test, corrosion test. These are the tests we are going to do that. So in the case study, they are followed these tests, but these tests are not necessary at all. If you are testing 3 or more, automatically you know the result. Suppose if you tested a compressive strength of the concrete, say compressive strength of the concrete is to be designed M50. So that means you have to go for the compressive strength is to be 50 newtons per mm square. So if we tested with the help of the either the rebound hammer or the ultrasonic pulse velocity, it is the 50 newtons per mm square. What is the design and what is the tested is to be okay. Suppose if it is 40 or 30, automatically you know that some deterioration will be occurs. So whatever the design compressive strength of the concrete is to be reduced to the 20 newtons per mm square after 10 years or 20 years because of the so many reasons. I don't want to say that only one reason is that for reducing of the strength of the concrete itself. There are so many reasons. So we have to follow the proper design mix or not, whether you have to go for quality of the material, quality of the labor, quality of the inspection also, quality of the scaffolding also. So whether the scaffolding is to be removed as per the standards or not. So columns as per the code book IS 456 2024 to 48 hours. So instead of 24 to minimum maximum 48 hours, you have to remove the scaffolding 10 hours or 12 hours. What is the original strength you don't get? So that's why the deviations. If you are deviate all the things, removal of the props, either the slabs or beams or columns or the whatever the things for a quick completion of the project, you don't follow the standards, automatically you have to reduce the strength itself. So instead of M40, you go for M30, you have to reduce the 10 newtons per mm square compressive strength of the concrete. So instead of 16 mm, you are going to use 12 mm. So instead of 20 mm, you are going to use 16 mm. Instead of 25 mm, you are going to use 20 mm. So these are all the deviations, these are all the differences. We have to be used with respect to the design. Design of the column is different, execution of the column is different, maintenance of the column is to be different. These three are very, very important. What is the design? We have to be execute as per the design only, don't be deviate. Suppose if any maintenance will be occurs, so you have to do the maintenance properly or immediately, otherwise the deterioration will be starts. Is it clear or not, my dear student? So that's why you don't want to deviate the design strengths or design values. Suppose the 20 mm is to be designed, should use 20 mm. 16 mm used, you have to use 16 mm. So 8 mm rings you are going to use, you have to provide only 8 mm. Don't go for 6 mm. Don't go for 10 mm also. I am already says that balanced section, under reinforced section and over reinforced section. Don't go for over reinforced section. Over reinforced section, the code will be reject. You don't want to go for more reinforcement. You don't want to go for less reinforcement. You have to provide whatever the reinforcement required, you have to provide. Otherwise, negative stresses will be developed inside the structure only. So in this case study, he has to do that rebound hammer test and delamination sounding method, carbonation test also. So, and pH test and ultrasonic pulse velocity also. Next, rebound hammer test. So, rebound hammer test, you know very well, in the laboratory also, you have to do that. As per the research, the compressive strength of the structural member is more than 40 MPa. There is a probability of carbon attack. So that it is recommended to go for a carbonation test. So, the minimum value of the compressive strength which is obtained from the stress is 16 is categorized as the poor. I know I told earlier also. So, original is 40 MPa, but the tested value is to be 16 MPa. So, it is a very, very poor. So, whatever the particular member you have to be tested with the help of the rebound hammer test, we are getting the value of the 16 newtons per mm square, and but original is 40 newtons per mm square. That's why he says that it is the poor, the lesser value of the compressive strength reveal as poor strength and poor quality of the concrete. So 40 newtons per mm square is to be your design, but you are getting unfortunately 16 newtons per mm square. How much less? Nearly 24 newtons per mm square. You are getting the less value that indicates poor quality and poor strength of the concrete member also. So after that, go for carbonation test. So as per obtained result, the depth of the carbonation is to be more than reinforcement level. There exists greater than 60 mm. So the carbonation test gives the depth of the carbon attack on the structural member. So why we did the carbonation test in the laboratory? So how much depth of the carbon is to be entered in a particular member, we have to do that carbonation test. From the obtained result, the depth of the carbon is up to reinforcement level, the structure is considered completely carbonate. So it is more than 60 mm, it is the completely carbonate structure only. So delamination and sounding method. So this is also shows that yellow sounds at the bottom of the member itself. Next, conclusion. What is the conclusion of a particular member? I have to tell now itself. After that, I have to finish. So, in this class, we had discussed about a real case study. It is a practical approach and compared to the theoretical approach. In the theory, we know that what is the rehabilitation and what is the retrofitting of the structures. What is the introduction? Yesterday, we discussed about what is the corrosion of the steel reinforcement, what is the role of the corrosion of the steel reinforcement, what is the mechanism of the corrosion of the steel reinforcement. If the corrosion of the steel reinforcement is to be occurs, what happened, what type of the precautionary measures we are going to take, we have to be discussed. So, what is the conclusion of this present PPT or present video is that you should get some practical knowledge, practical exposure about what is the importance of the rehabilitation and retrofitting of the structures if you are applying for a case study. So, if it is applied to the Mangalore, if you apply to the Hyderabad also, if you apply to anywhere in India, anywhere in the world also. So, you go for the site and you have to see whatever the defects you observed, whether in the columns or the beams or the slabs or the floors or the walls, brick walls or the shear walls, whatever the things, first of all, we have to verify physically. So, after that, we have to take the prints clearly, not visible means in completely visible, you have to take the photographs. After that, you have to pin it one to one and you have to write whether it is the column problem or the beam problem or the slab problem or the shear wall problem or the staircase problem or the floor problem, how many floors it has to be. So, whenever the structure is to be constructed, so what is the purpose of the structure, whether it is the commercial purpose or the industrial purpose or the residential purpose or the school building or the engineering college building or hostel building or hospital building, you have to mention, or warehouses you have to mention. So, this is a sample case study I had taken, Mangalore warehouse in Karnataka state. You can take any case study. So, this is the way you have to analyze like that. So, what is the final conclusion of my present video is that it is noticed that the roof of the existing structure is to be highly hazardous and replacement is to be mandatory. So, the problems are very crucial problems. The problems is to be very expensive problems. That's why mandatory is to be required to replace that. The existing masonry is to be highly damaged and significantly require instant repair. So, after the final results, so what is the possible value, what is the permissible value, what is your actual value, based on that you have to write. You have to replace the particular member or you have to repair the particular member, or you have to do anything, you have to write the remarks. So the existing masonry is to be highly damaged and assigned for the instant repair. Immediately required repair is to be required for the masonry walls. And next, vertical members, the column members are lose their strength due to the high range of the cracks, spalling of the concrete, and internal cavity also. Internal cavity means is to be occurs because of the stresses developed because of the corrosion of the reinforcement. The bottom portion of the vertical members are impaired majorly compared to the other portions. So finally, what I try to say means this is a physically damaged structure. So because of improper design and because of the improper construction, because of the improper execution. So not improper design. Design is to be proper, but the construction is to be not proper with reference to the existing design, and maintenance is also very poor. That's why the structure is requires immediate repairs and immediate necessary requirements. Okay. So these are the reference slide links. Thank you very much.